Hello everyone, my name is Ravi Singh and I am currently pursuing my B.Tech in Computer Science from Bennett University. Today, I am going to present a presentation on augmented reality. So, this is the outline of my presentation. First, we will discuss the introduction and the history of the AR. Then, we will discuss the working and the current challenges facing by the AR today. Then, we will discuss the AR experiences or the application of it. So let's start with the introductions. So many of us have seen a movie Iron Man. In this movie, the Tony Stark designed his Iron Man suit through its holographic image. If you have seen this type of movies, you will have some idea regarding the concept of augmented reality. We have all come across augmented reality at some point in our lives. In layman terms, augmented reality is a technology that enhances the real world by affixing layers of digital elements onto it. These elements include computer-generated graphics, sound, or video effects. Now let's discuss about the history of AR. In 1968, Ivan Sutherland built the Sword of Damocles. His goal was to create the ultimate display. He wanted to make a digital interface capable of transforming the physical world. The term augmented reality was first coined in 1990 by Thomas Cadwell and David Mazel, the two Boeing engineers working on a simple see-through headset that helped the airplane engineers in complex wiring semantics. According to their documentation, the goal of the augmented reality was to enable the cost reductions and efficiency improvement in many of the human-involved operations in aircraft manufacturing. Now let's discuss about the Google AR. Google enters in the field of augmented reality by launching the Google Glass, a head-mounted display that took the form of the smart glass. It is still used today in variety of enterprise applications. After Google Glass, Google's next AR play was Project Tango. Project Tango was a combination of the custom software and additional hardware for unique depth sensing smartphones. Tango-enabled phones could track the world around them. As a result, AR were capable of rendering unique digital overlays onto the real world. In 2017, Google announced AR Core, an evolution of Tango platform. AR Core is an application programming interface or API for building and developing mobile AR experiences. So what makes AR feel real? On the basis of the motion tracking, first one is the accelerometer. It basically measures the acceleration, which is change in speed divided by time. Simply put, it's measure of change in velocity. Acceleration forces can be static, continuous like gravity, or dynamic, such as movement or vibration. The next thing is gyroscope. Measure it basically measure or maintain the orientation and angular velocity. When you change the rotation of your phone while using an AR experiences, the gyroscope measures the rotation and the AR core ensure the digital asset respond correctly. Now, on the basis of the location based, the first component is phone camera. Phone camera with the mobile AR. Your phone camera supplies a live feed of the surrounding real world upon which AR content is overlaid. In addition to the camera itself, AR core capable phones like Google Pixels rely on the complementary technologies like machine learning, complex image processing, and computer vision to produce high quality images and spatial maps for mobile AR. The next component is magnetometer. It basically gives the smartphone a simple orientation related on Earth magnetic field. Because of the magnetometer, your phone always knows the which direction is north, allowing it auto-rotate digital maps depending on your physical orientation. This device is key to located location AR-based app. The next component is GPS. It is basically a global navigation satellite system that provides geolocation and time information to a GPS receiver, like in your smartphone. For AR core capable smartphones, this device helps enable location-based AR apps. Now let's focus on the state of the AR, that is placing and positioning of the AR object. The first of these behavior is the place. A stationary AR object needs to stick to one point in the given environment. This can be something concrete such as wall, floor or ceiling, or it could be suspended somewhere in the mid-air. Whatever the case, placing means These objects stay where they are positioned, even when the user are in motion. The mug or on your coffee table doesn't jump around when you move your head. If you look away, it's right there when you look back again. For AR to maintain the illusion of reality, the digital object needs to behave in the same way real ones do. Now, the next one is the scale and the size of the AR object. In addition to the sticking wherever they are placed in the real world, AR objects needs to be able to scale. When a car is coming toward you from a distance, it starts out small and gets bigger. A painting viewed from a side looks very different when you walk around and face it head on. Our physical distance from a given object and our orientation around it changes how they appear to us. A well-constructed AR experience will incorporate objects that are not only appropriately placed but will look different if you stand right next to it, or below it, or above it, or view it from some distance. This is called scaling. Together, placing and scaling are what AR objects from digital novelties to assets that could be potentially replace real-world counterparts. Now let's discuss about the current challenges facing by the AR today. Imagine this, you time travel back to the year 1800 and grab the first person you see. You bring them back to the present and sit them in front of the computer. Without any instructions, do you think they will be able to navigate the internet? Will they understand how to use the mouse and keyboard? Will they even able to turn it on? Probably not. Time travel may not be possible yet, but AR is. There is a term in the technology called user interface metaphors or UI metaphors. These are the common types of interface that apply to multiple sets of common technology. For example, your phone, your computer, maybe even your refrigerator all come equipped with a QWERTY keyboard these days. The hard part about AR is that it is such a new technology that it doesn't really benefit from any UI metaphor. Should we use our hand or our eyes to navigate menu? Should we select items on this menu with a tap or a snap or our voices? Should we even have a menu at all? When it comes to AR, UI designer needs to start from the ground up to research, design and test what works best for the unique platform. The next challenging is cost. The most common concern was the perceiving cost of implementing the new technology. Of course, there are multiple ways of implementing AR, all with the different price points. Customizing an app may cost a few $1,000s, but if a company needs a custom app built up from the ground up with the unique components, the price tag could run well into the six figures range. Take the furniture retailer IKEA, for example. Their AR-powered app allows customers to shop their site as well as to scan their homes with their smartphones to virtually display and determine how products will look before purchasing them. While the actual price IKEA paid is unknown, analysts had estimated a cost of $30,000 to $60,000 for the build and implementation based on the market rate for the AR app developers. Now the next one is the 3D barrier. The pretty much everybody knows how to take a photo, but there was a time when that skill resided only with the professionals. This equivalent of this AR in three-dimensional design. In AR, things exist primarily in three dimensions. It is a misconception to say that everything in AR has to be 3D, but the vast majority of asset, application and experience will require at least a little 3D design knowledge at some point in our creation. Currently, the base of the people with the skill is still small. For AR to grow, the adoption of 3D design theory, skills and language needs to become much more widespread. Now let's understand the type of AR experiences or the applications of the AR. So let's start with the shopping. So as AR get integrated seamlessly with the real world, it has proven to be powerful medium for the shopping and the retail. It can let you try on a watch, a shirt or a new shade of makeup all without ever leaving your home. But the top use case of the AR shopping right now is furniture. According to the few major studies, furniture is the number one thing people want to shop for with AR. Major furniture retailers like IKEA and House have put idea like into this practice. The next application is gaming. In 2016, everyone have played Pokemon Go that will become a first viral AR game. Since then, we have seen the launch of similar games from mainstream franchise like Harry Potter, The Walking Dead, Ghostbusters, and we will see many more games like this in the coming years. The next one is the social media. One of the most obvious use of for AR in social media is social sharing. Snapchat was the first media platform to fully immerse AR. Facebook also followed the lead with its own AR camera fixed platform. Google is working to develop an initiative platform for creating content for social AR through an AR sticker. Sticker allow users to import animated and interactive 3D object for use in social media. The next one application is business. When it comes to the business, AR core enable experience for many different kind of professional organizations. Warehouse can build helpful navigations and instructions for the workers. Architecture firms can display the design in 3D space. Retailers can give customer novel ways to engage with the product. And advertise can reach consumer with the immersive campaign. This is just a tip of iceberg. The power of AR is that it lets users build a relationship with brands inside their physical space rather than they're trapped behind screen. The next application of AR is in education field. Demonstrating complex subject is another one of the AR greatest capabilities, allowing learners to engage with spatial content visualized right in front of them. For example, a student can explore a strand of DNA. The last application of the AR, that is healthcare. AR is already used in medicines, and that is only increase the technology mature. Doctors and nurses are using AR enhanced visualization capabilities to more successfully diagnose patient, plan procedures and execute treatment plans. Now the next is conclusion. So I want to conclude by saying that augmented reality is another step forward into the digital age, as well as we will soon our environment change dynamically either through a smartphone or a glasses to display enhanced content and a media right in front of us. Or basically augmented reality are going to become a mainstream soon. Things are already changing, and before we know it, we are going to living in a world more virtual than real. Thank you. I hope you enjoy our presentations.